everyone. Welcome to this new episode of our Student Spotlight series, where we are able to showcase some of the work our past students have done. I'm Charlotte. I'm one of the outreach coordinators here at CCIR, and it's our pleasure today to welcome with us Arnav, who did one of our one-on-one mentorship courses. So firstly, Arnav, can you just introduce yourself? So tell us where you're from, what year you are in school, and then what the topic of your one-on-one mentorship was.
Yeah, so I'm Arnav Reddy. I'm a junior, rising senior at Bellarmine College Preparatory in San Jose, California. And the topic of my paper was in biomedical engineering on PEDOT PSS as a discrete electrical component in skin-based technologies.
And then what made you seek out CCIR to do, I assume your course in general was biomedical engineering,
Yes.
Is that right?
Yeah.
So what made you seek out CCIR to find a course for this?
I had already done like basic stuff before in terms of biomedical engineering. I had done camps and programs at different universities. So I thought the next step forward would be to do research and to publish that research. And I found that CCIR had some good resources and good mentorship opportunities. So I decided to go with CCIR for research.
Great. And then can you tell us what interests you in biomedical engineering, or what interested you in doing the one-on-one mentorship?
Yeah, so I chose biomedical engineering because I've had an interest in medicine and an interest in engineering from several years in my school's robotics program. I decided that the most interesting aspect of it would probably be combining both of those, which is how I got into biomed for my sophomore and junior year. And I decided to go on the one-on-one because I wanted to understand more of it. I feel like I would have the best experience talking to a one-on-one mentor, so I could ask him a lot of questions and connect with him better.
And then can you just repeat for us what the topic of your paper was, and then we're going to talk a little bit about that.
Yeah, so the topic of my paper was PEDOT PSS as a discrete electrical component for skin-based technologies.
And can you explain kind of just to the lay person what that means?
Yeah, so PEDOT PSS is a polymer coating for electrodes. And I was comparing the effectiveness of PEDOT PSS as a coating on an electrode to the control of metal. And the paper was discovering if PEDOT PSS was more effective than metal as an electrode for technologies like ECGs and EEGs, all those that connect to skin. And we're comparing the value of impedance, which is just the overall resistance to an alternating current. And the project was just to see which one was more effective and which one could be used more in all these medical applications.
Interesting. And then can you tell us, so what were I assume were you using an existing data set?
Yeah, so we had an existing data set from a different external paper that had already tested PEDOT PSS coated electrodes versus metal electrodes. But since this was based on skin, we had to create our own equations or formulas to garner new values that we could place into the graphs for the length. So the formulas created were based for the electrode itself, and we got them from external paper. And what we did was we placed all those values from the other paper into a graph and created a line of best fit. And that line of best fit would give us a formula for then we could use to get values for our paper.
Okay. And then did you have any interesting findings or maybe things you weren't expecting to see?
Yeah, so the main expectation of the paper was that as the size and the frequency increased for the tested area, the impedance would decrease, and we saw that with the PEDOT PSS. So we didn't really have any like conflicting or any interesting about that, but we did find something interesting with the metal, in which since we're testing different sizes and those different lines would be colored, we saw all of those lines converging into a singular one on the graph until it reached a certain frequency in which it would flatten out. I thought like having a singular line for the impedance for a metal was pretty interesting because I didn't expect that.
Can you tell us what's kind of explain to someone who's not super knowledgeable about the topic, what's the importance of that?
Yeah, so it just shows how in that specific why it happened was because of the dominance of the resistor in the circuit, which means that the metal was less effective at those lower frequencies compared to the PEDOT PSS coated electrode, which he found important because that's what we're trying to prove in the paper, that PEDOT PSS coated electrodes work a lot better than plain metal electrodes for these skin-based technologies. And that's what the singular line proved.
Mm. And then can you explain just the importance of your findings to the field or for the general public as a whole?
Yeah, so basically, a lot of electrodes are used in a lot of medical applications in order to record signals and see if that tissue is healthy. And a lot of electrodes can be, a lot of these readings can be disrupted by noise, which is just how much of impedance is affecting the electrode itself. So by wanting to reduce that impedance, we can reduce the noise, and that's what PEDOT PSS code electrodes are going to help us achieve, to reduce that noise so we can get more accurate readings and more accurate diagnosis for specific medical technologies.
Okay. And then last question about your specific paper. Can you tell us what your process has been like with the publication so far, and what support your mentor or CCIR has given you for that?
Yeah, so for publication, I first went to a conference in IEEE, and I delivered a presentation on the paper itself to a bunch of professors and students who were also doing presentations. And I went to Taiwan for that. So my teacher or my mentor gave me a lot of support in helping me like derive the values and then like cleaning up the data, because he had a lot of experience with computational technology that we were using. And because of that, I was able to get a much cleaner graphs and a lot of ease. He was able to facilitate the process. He also helped me a lot with like the writing terminology, because he had so much experience in the research. He would help me like make the words more professional and a lot more clean looking. CCIR helped too with getting me the topics, like the papers that I needed to read, since a lot of them were locked behind paywalls. So CCIR helped with a lot of the resources and application stuff. Yeah.
And then you said you were trying to publish as a manuscript as well. Is that right?
Yes.
So now we're going to shift and discuss your just general experience with CCIR. So the first question, can you tell us what your experience was with this program and then doing a kind of high level research project like this as a high school student?
Yeah, so as a high school student, I didn't have too much experience with computational technology and electrical engineering, but I did have some basics in understanding like biology, since I had taken some classes at school and also some external programs too. But my mentor mostly helped me through understanding electrical engineering and computational technology. So a few of their first meetings were just based around him teaching me all this new stuff. And because of that, it made the experience a lot more easier, because I felt a lot more comfortable doing things on my own and when I had time to do the research on the project on my own. So I think that the experience was pretty good because of how much I was able to understand, how much I was comfortable with.
That's great. And then how was the research process and research experience compared to papers or projects that you've done in school before?
Yeah, it was a lot longer, obviously, because it was from like a January and so on. But it was a lot more easy to do because I was very interested into the topic, and my mentor being there to help me out with a lot of this made it a lot easier for me to complete everything. In comparison to school, school papers are pretty short and they don't delve into everything as explicitly as this does. So I had to research a lot more into specific topics to understand what really was going on, because just being surface level wasn't enough for the paper. So I thought basically the main differences were just the length of time, how much I needed to research into it, and having someone there to help me.
And then can you tell us, so I know with biomedical engineering, it's quite a niche topic, especially for a high school student. Many undergraduate students don't even get to take courses that specific yet. So can you tell us what it was like taking such a niche course compared to what you would have had access to otherwise?
Yeah, so since I already had experience with this, since UCSD offered a program for biomedical engineering, I already had some knowledge about tissue cultures and stuff, and also about the basics of introduction to research. But coming into this, it was more about I already wanted to do this, and I knew I wanted to do this because I had seen a bunch of papers that CCIR had published, and some of the papers that the professors had published. So, and since I read more about my mentor before I met him, so I could discuss what he had worked about. I think that I was pretty comfortable coming into it. I think the CCR helped me out a lot with finding a basis of where to start off of and learn more about the parts of biomedical engineering I hadn't learned before.
That's great. And then just a few last questions. Has this program given you any insights into your future? Do you think it's informed or shaped how you think of your path or your career moving forward at all?
Yeah, I think it has. I think that having done research now, I think I do want to pursue this into the future. So in university, I think I would probably want to do a lot of research. I think that's something I'm going to be looking at as I apply to colleges. I also think that it showed me another aspect of biomedical engineering, which only makes me want to push further into it because of how interesting I saw it was. And I know there's a lot more left to learn about.
And the last question, what would you say to someone who asked you what the value of doing a project or a program like this is, especially for a high school student?
I think there's a lot you could learn from this, especially since the mentor's there with you, teaching you a lot of this, and it's stuff that you won't be able to, and it's stuff that you won't be able to learn that much well on your own. So having someone with you can explain a lot of this stuff to you. I think it's also valuable experience if you're planning on pursuing into that field, because it shows you what a taste of it would be like if you went into the higher level of that field itself. So I think it's a great opportunity.
Yeah, definitely. So thank you so much for chatting with me, and congratulations again on your nomination to our Spotlight series.
Thank you.